Hi everyone, my name is Christensen. I'm a rising junior in computer science engineering, and I've been working for the past 12 weeks on a project called Human Computing for Electronic Design Automation with my advisor, Professor Valeria Bertacco, and current U of M grad student, Andrew D'Orio. First of all, a little bit of background on EDA problems and satisfiability. EDA describes a set of tools used to help engineers design and simulate electronic systems ranging anywhere from circuit boards to integrated circuits. These tools work by simulating the millions of primitives or solution paths that exist in these systems and are currently solved with heuristics and approximations. That's where satisfiability, or SAT problems, come into play. SAT describes a type of Boolean expression where we try to find an assignment for the variables such that the expression evaluates to true. SAT can be used to model many EDA applications. So since computers only use approximations to solve these problems, we started brainstorming some ways that humans might be able to solve them, and some things that humans are good at, such as object recognition, creative thinking, visual reasoning, such as playing the game Go, where humans can always beat computer algorithms, text summarization, and intuition, where people have the sense of being able to know a good move in a game, even if they can't fully explain why. So from our brainstorm came FunSat, our human EDA game. This is a screenshot of the game, and I'm going to describe what the board means. Around the perimeter, we have buttons that represent the variables of a Boolean satisfiability problem. You can click the button to turn it to blue to mean true, yellow to mean false, and if it's gray, it's still unassigned. The bubbles in the center represent the clauses of the Boolean satisfiability problem. Green is satisfied, red is unsatisfied, and gray is still undetermined. The goal of the game is to click the buttons and turn all of the bubbles green. So now I'm going to walk you through a quick game of FunSat. When you first load the game, the board will be completely gray. So I decide to click a button, and I'm going to toggle it to blue, and I see that two clauses in the lower right corner become true. Now if I right-click on this variable, I see several bubbles that are highlighted, which show the bubbles that depend on this variable. Now I see that if I turn this button to yellow, I'll turn three clauses green. So I do that. I'm going to play for a while until I have only one clause left unassigned. I'm going to use the same process, right-click on this clause this time, and I see two buttons on the right-hand side highlighted, and I'm going to change one of those to make all of my clauses green. So moving forward with this game, we'd like to extend it to become massively multiplayer, so we can handle large SAT instances, kind of like a map, as shown by our little Google Map picture. We'd also like to add some social incentive, some networking, team collaboration, so that people can work together to solve large instances. So in conclusion, we've determined that although EDA problems are difficult for computers to solve, humans have some special problem-solving capabilities that may allow them to be more successful than computers. So if you're up for the challenge and are interested in playing, feel free to visit funsat.eeks.umich.edu and try for yourself. Thank you.